Welcome to Lesson 7-2 about inequalities in two triangles. The first thing we're going to be looking at is the hinge theorem, or sometimes called the SAS inequality theorem. Simply stated, it says that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. We call this a hinge theorem because it resembles a door opening and closing. Let's take a look at the animation in the link. Okay, suppose you take two sticks, not necessarily the same length, hinge them at a common end and attach a rubber band at the other end. Then you can open and close them to form triangles as you see in the picture. If you notice, the more it's open, the longer that rubber band has to stretch. And so if we extend this to looking at two triangles, what we can find is that if our two sides are congruent, and that's important, those two sides are marked congruent, and these two sides are marked congruent, then the angle that is more open has to be across from the larger side. So here, this angle is further open, and so that has to be a larger side. The smaller angle is across from the smaller side. Hey, there are some examples below, and I would encourage you to take a look at those if you are interested in more information about this. But we're going to go back to the notes at this point. So in this example here, it says that two triangles with sides AB congruent to JI and AC congruent to JH have the included angles where the measure of angle A is larger than the measure of angle J. So I'm marking one larger and the other one smaller. If you look at this, the side across has to be my longer side. The side across my smaller angle is going to be my shorter side. That's what the hinge theorem tells us. In other words, if one hinge is open wider, its opposite side is longer. Below we have another example showing this. Smaller hinge angle, shorter side, wider hinge angle, longer opposite side. It is important to note, however, that the sides around your hinge angle must be congruent. As an example to show what we are not talking about, let's take a small angle and a much larger angle. Clearly, the angle on the right is larger than the angle on the left. But if I extend my smaller angle here and enclose these to form a triangle, the green side is clearly longer than the blue side, even though it's across from a smaller angle. This is not the hinge theorem because my sides are not congruent. Be careful with this. And don't let that confuse you. Now let's move on to the converse of the hinge theorem. This is kind of a reverse. This is our SSS inequality theorem. When two sides of a triangle are congruent to two sides of another triangle, if the third side is longer in one triangle, then the included angle has to be larger in that triangle. So it's the same situation here. If I know that side BC is longer than side IH, then I can make the conclusion that angle A has to be greater than the measure of angle J. In other words, if the third side is longer and the other two pairs are congruent, its opposite side is larger. So in these problems, what you're asked to do is make a conclusion based on either the hinge theorem or its converse. So let's look at examples below. We're going to make a conclusion based on the hinge theorem or its converse. So let's look at what we know. I have two sides marked to be 10, so I know that those two sides are congruent. If I'm looking at the two triangles, side EG is shared, so I know that it's congruent to itself. My hinge angles would be the angles that connect those two sides. So it's going to be this angle here and this angle here. So my hinge angles would be angle FEG and angle HEG. Since FEG is 30 degrees and HEG is 25 degrees, I know that the measure of angle FEG is greater than the measure of angle HEG. Based on that, I can conclude that the side across from the larger angle, which is FG, has to be greater than the side across from the smaller angle, which is side GH. Knowing that FG is 6 units, I know that 6 is greater than GH, or I could say that GH is less than 6 units. Now let's look at B. For B, I'm noting that these two sides are congruent because they're both marked 10. These two sides are congruent because they're both marked 8. That makes my hinge angle the angle that connects those two. So my hinge angles would be angle P and angle T. The side across from angle P is the side QR. The side across from angle T is the side RS. And I can see, since QR is 5 and RS is 5.1, that QR is less than RS. Using the converse of my hinge theorem, then, I would know that angle P has to be less than angle T. And those should be the measure of angle P and the measure of angle T. And that's the end of your video notes. You should be going on to your online work, your Tier 1 assignment, and your knowledge check.